We are group 7. This is microelectronics. I am Billy Bustamante. What is microelectronics? It is defined as that area of technology associated with the applied to realization of electronic systems made of extremely small electronic parts of elements. The term microelectronics is normally associated with integrated circuits. As the name suggests, they are related to the study and manufacturing of very small electronic design and components. These devices are made of semiconductors materials. Microelectronics include active, like transistors and diodes, and passive components. Which is the impact of a world economy? Microelectronics has an enormous economy leverage as any progress there's spurs innovation in downstream industries and services, while computing, telecommunication, and entertainment products existed before the advent of the microelectronics. Today's information society would not have to be possible without. Microelectronics is the enabler of information technology. Advantage of microelectronics over discrete components. Fabrication process is simple, low power consumption, production will be in bulk quantity so that the cost getting reduced. More novel component will be fabricated in a single chip. Heat dissipation is reduced, more reliable, space is less, weight is less. Cost of production of electronics circuits due to batch production is reduced. Classification of integrated circuits based on an application, linear and digital, based on fabrication techniques, monolith and hybrid, based on technology, BJT, MOSFETs, based on device counts, is small scale integration, medium scale, large scale, very large scale, and ultra large scale. This is a table for each classification about amount of devices inside. And this is a scheme about this classification of integrated circuits, which functionality, application specific, and general purpose. And this is a diagram about fabrication of one active element, like transistor. This is the step-by-step how is fabricated this element.
Now, talk about current mirror. It is a circuit that shows a constant current. The current mirror is one of the most important building blocks of analog integrated circuits. Based in the integrated circuit design is based on the use of constant current source. Basically, in the integrated circuit, a constant current is needed, a guided reference current, which allows to replicate this current in the several amplifier stage in the order to bias. Then this process is called current steering. Next. Why is it called mirror current? The circuit of a simple mode constant current source shows the circuit, the heart of the circuit in the transistor Q1, the drain of which is shorted to its gate, thereby forcing it to operate in the saturation mode, which where we have the needed channel length modulation. The drain current of the Q1 is supplied by a VDD through resistor R, which in the most case will be also the EC chip since the gates current are zero. where the current through R is considered to be the reference current of the current source, and the N in the is denoted A refer. Uh, can be used to determine the value required for R. Now consider transistor Q2. It has the same behavior as Q1. Thus, if we assume that its operation in the saturation is drain current, which is the output current, the zero of the current source will be equations the is zero. We have neglected the channel length modulation and enable use to relation the output current is zero to reference current. I reference as follows. Uh, yeah. The special connection of the Q1 and Q2 provided an output current is zero that is related of the reference current I ref. By the aspect ration of the transistors, in the other words, the relationship between E0 and Eref is slotted determined by the geometry of the transistors. In the special case of identical transistor, current zero equal a current reference. In the circuit simplet replicates of the mirror reference current, the output terminal, the hash given in the circuit composite of the Q1 and Q2, the name current mirror, a name that is used irrespective of the relation of the dimensions. Next. Effects of the volts is zero in the current zero in the description about for the operation of the current source. We assumed Q2 to be operation in saturation. This is essential if Q2 is to supply at the constant current output. To answer the Q2 is insaturates the circuit to which the drain of Q2 is to be continued most established a drain voltage V0 that satisfies the relationship or equal or equivalent in terms of the overdrive voltage V of Q1 and Q2. In the other words, the current source will operate properly with an output voltage V0 as low as V0, which is a fake tenth of the volts. In summary, the current source in the current mirrors have a infinity output resistance RS0. Also, recalc that for a given process technology, VA is proportional to the transistor channel length. Thus, to obtain height output resistance value, current source are usually designed using transistor with relatively long channel. Finally, note that we can express the current in zero is yeah. Next. The BJ or BJT circuits, the basic BJT current mirror is as shown. It was a fashion very similar to that of the most mirror. However, there are two important different fields. The non-zero base current of the BJT or equivalently the infinity beta causes an error in the current transfer ratios of the bipolar mirror. Second, the current transfer ratio is determined by the relative area of the emitted base junction of the Q1 and Q2. Next. Yeah. Bipolar mirrors with bias current compensation. Show a bipolar current mirror with a current transfer ratio that is much less dependent on beta than that of the simple current mirror that reduces dependence of the beta is achieved by including transitor Q3, resulting in a much smaller error current that has to be supplied by a current reference. It is a basis on the assumption that Q1 in the Q2 are matched in the thus have equal collector current another equation on the node level H gives. In the current transformation in the mirrors will by, which means that the error to definitive beta has been reduced from 4 beta in the simple mirrors to 4 beta 11. So, the good receipt remains approximately equal of the simple mirror, namely R0, note that if a reference current IRF is not available, we simply connect node X to the power supply VCC throws a resistant error, the results in a reference current given by. Next. Is my signal operation of the current mirrors. So a most current mirror bisect with a DC input current in the FET with a small signal input current, not that the BGs in the ED2 are the resulting DC quantity, with BGs in the E0 are signal quantity. We are assuming that the voltage in the drain of Q exceeds the minimum required to keep Q2 in saturation, replacing Q1 and Q2 with their small signal model result in the circuit, which is equal to the DC or larger signal current transfer function, a clear indication of the excellent linearity of the current mirror. We concluded that the current mirror is an excellent current amplifier if it has a relatively low input resistance once for constants Gm, a relatively high output resistance in the gains determinate. Next. Current mirror circuit with improved performance want the accuracy of the current transfer ratio of the mirror to the output resistance R0 increase the minimum DC voltage required across the current source. Next. Next. Finally, the other circuits, the configuration, the current mirrors preview back. The cascado most current mirrors, the Wilson bipolar current mirrors, next the Wilson most mirror y the Wilson most mirror modifieds. Next. The Wilder current source.
Good. Now, we are going to simulate in Proteus software a current mirror circuit with both BAT and MOSFET transistor. In the right side, the current mirror circuit using BJT transistor NPN is shown here. Two identical transistor pair is used. Instead of the programming resistor, a potentiometer is used to control the current flow on the live simulation. An ampermeter is connected to both input and an output side. As the simulation goes, the input current is almost same across the secondary side. Now, in the left side, the current mirror circuit uses MOSFET, channel P and channel N transistor. The transistor on the left is in saturation region of the drain source voltage is less than or equal to supply gate voltage. For the case transistor on the right, it will also remain in saturation mode as long as the output voltage is greater than the saturation voltage. Therefore, the input current across the left transistor will control directly output current of the right transistor. MOSFET device function like this. The drain current reflector the function of the gate to source and drain to gate voltage. And that was an example of a current mirror circuit. I see the ampermeter, the current is same and both circuit. There are wide applications of the current mirror circuit in the fields of integrated circuit manufacturing. The reference current source is created using the current mirror circuit. By using this technique, multiple reference points can be created from a single source. Hence, changing one reference point also changes the current source across different parts of the circuit. Thank you.